Saxon Algebra 2. Hey, look, it's new book day. I'm very excited. Look at that huge glare. I see you have a huge glare there. It looks like the mothership is landing on my notebook. But I just wanted you to see I'm super excited. These are some really nice notebooks that I found on Amazon that are sold in a pack of the same colors that match all of John's textbook cover colors. So imagine how amazingly excited that made me, right? Because I can buy one pack and have all the right colors for my class notebooks. And you know what could make me happier? I know, you too. Lesson 53, we're going to talk about unit conversions, and then there's one tiny little other second topic that John tacks on at the end. It is algebra and not geometry, so don't worry. All right, let's review these unit conversions. We're going to focus on a couple special factors, but by and large, it's the same kind of stuff we've done for a long time. Okay, let's dive in. Is there any other way to learn math but just to dive in? I don't think so. Use unit multipliers to convert 7,560 centimeters to kilometers. That's not a real word. Kilometers. Okay, I write that down and I notice two things about it right away. I notice that we're converting lengths, right? Centimeters and kilometers are both lengths. And that means I'm working in one dimension. That means I only have to use each unit multiplier once. You know how sometimes if we're doing area or volume, we have to use the same multiplier more than once? This is just length, so I don't have to worry about that. The other thing I notice is that this conversion is going from metric to metric, right? Both of these are metric units. So I don't have to worry about climbing through the wormhole between metric and English systems, right? We'll do that later. Okay, so all I have to do is figure out how to get from centimeters to kilometers. And John doesn't, sometimes he gives us a hint and he tells us how many to use, but this time we have to figure it out for ourselves. Okay, so what I'm gonna do is write my first box down. And I know that I can go from centimeters to meters in one step. That'll be easy. But then I'll need to do a second one to go from meters to kilometers, but that's okay. 2 boxes I consider to be a pretty good deal. All right, so there's my plan. I can put this over a 1 if that helps me. And I remember that I'm multiplying all of this, and then that will give me the answer. I remember that I want to set these up so that I'm canceling as I go. So for this first one, I'm going to go from centimeters to meters. I want the centimeters on the bottom so they'll cancel with these, right? Meters goes up here. Now I ask myself these important questions. Which is bigger, a centimeter or a meter? A meter is like half your dad's height. A centimeter is like that much. Okay, how many centimeters are in a meter? The word cent always implies 100. Like how many pennies, cents are in a dollar? 100. Okay, these cancel. And now we're in meters, off to the races. Now we want to go from meters to kilometers. Okay, meters is up here, so I know I want it down there. I'll put kilometers up here. Which is bigger? A kilometer, if you go to Canada, all their road signs are in kilometers. So a kilometer is like similar to a mile. And a meter, most dads are about 2 meters tall. So that means this is a lot bigger. Unless your dad is super tall. And then he's closer to a kilometer than a meter. I don't think any of you have a dad whose height is close to a kilometer. Not even the BFG is that tall. You know the BFG? It's a book, Roald Dahl. He's a giant, the big friendly giant. Okay, but I digress. Story of my life, right? How boring would these lessons be if I never sidetracked? How short would these lessons be if I never sidetracked? But you know what? You would just be falling asleep and it would be so boring and you'd never hear what I said because I would just be droning on about, what order the variables are, blah, blah, blah. It would be boring. Okay, but now I'm just rambling. Okay, so a kilometer is bigger. It gets the 1. How many meters are in a kilometer? Whenever we see this prefix, we know it means 1,000. Okay, so these words give us hints as to how many times we multiply. And remember, the cool thing about metric is that it's always a 1 and zeros. They don't use weird things like 2.54 and 5,280. Okay, so now these cancel. We're in kilometers, and that's where we want to be. So the last thing we need to do is just gather up all our numbers. It's 7,560 times 1, we can ignore that, over 100 times 1,000, right? This is a perfectly lovely answer for me, but, and we could write kilometers, but we can also very easily write the simplified version of this. I just wrote those digits down, and I want to divide it, / make it smaller, by 1, 2, 3, 4, 5 decimal jumps, right? We make a decimal jump for every 0 because that represents a power of 10. So if my decimal is here, I want to make it 5 times smaller. 1, 2, 3, 4, 5. Put the decimal there. I fill in the 1 empty space. So my answer would be 0.0756 kilometers. That is the equivalent of that. Oh, this is so nice, right? When we're just using powers of 10 to adjust, the work is much easier, isn't it? Okay, let's do another one. I don't want to try and squeeze it down there. I don't want the first page of my beautiful new notebook to be scrambled and gross looking. That'd be depressing. I sat in the squeaky chair again tonight, so sorry. Example 53.2. Use unit multipliers to convert very big number square centimeters to square kilometers. Okay, this is the number. $15,740,000 square centimeters. So I'm going to write centimeters. That's all over 1. And then I want to convert it to a number that is square kilometers. Okay, this is similar to the one we did last time because we went from centimeters to kilometers, and we know it goes in 2 steps. So what I'm going to do is I'm going to write those 2 steps, but I'm going to remember that because we are now converting an area, I'm going to have to use each one 2 times, right? John does not do this, but this is my little trick so that you don't have to get a fold-out paper and write for days. We're going to remember that each of these represents 2 multiplication because we're dealing in an area. Okay? So, the first thing we want to do, let's write down our map. We're going to go from centimeters to meters, and we're going to go from meters to kilometers, just like before. Okay, centimeters on the bottom, and then meters on the top, and it's going to be a meter is bigger, and there are 100 centimeters in a meter. We went through all this last time. I don't have to rehash it. Now, this cancels, and I'm going to slash this twice because we're using this 2 times, right? And so that's all good. Now we're in meters, which is where we want to be. Now we're going to use meters down here, kilometers up here. A kilometer's bigger. This is 1,000 times, and I have to remember I'm doing it twice, just like last time. So 2 of these against 2 of these, and now we have this twice, which matches to that. All right, that looks pretty good. All we have to do now is summarize our number. On the top, we see it's just 15740. I'm just copying this first number because that's in the multiplication. And now we have to divide it by, and we use each of these numbers twice. This is a nice little way to save some writing, but we have to remember our own trick when we're copying out the actual number. This is kilometers squared, right? Now that I'm writing the answer, I don't have to write it twice. I can do it like this. And now we're going to talk about bumping out all these decimal places. So what I do is I write the number over again. I know I'm writing, you wouldn't have to write it this many times, but I like to make sure you're getting what I'm doing. We count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to make this number smaller by 10 decimal places. One jump for every zero. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill in with the zeros. That means our answer is, you can put a lead zero before the decimal if you want. It's kind of fancy. 0, 0, 1, 5, 7, 4 kilometers squared. That is the right answer. All right? So it's kind of a pain, but when we work in the metric system, it's so easy to simplify our numbers that we go ahead and do that, right? If this was the English system, we wouldn't have such cute little numbers in here, and we could leave it because it's a big, sassy mess. All right, these are easy to fix. All right, so those were two problems where we were staying within the metrics. One was length, one was area. With area, we had to do it twice. Now we're gonna switch over and review with two more problems when we're combining, when we're going from English to metric or metric to English. So let's practice those. There are two of those problems. Gracie's lying on my feet. My feet, it's quite warm and comfortable. 53.3, are you ready? We're going to, sorry, flopping pages around. We're going to use unit multipliers to convert 32 yards to meters. Okay. A yard and a meter is a lot the same. A yard is equal to 3 feet, right? And a meter is roughly similar, but again, we're changing from one system to the other, so we're just gonna have to do this little calculation, all right? Now, we know that the portal, the place where we go from yards to meters, is inches to centimeters. We can go in either direction, but that's the portal. That's what we have to climb through. That's the wormhole that allows us to travel between the two systems. So we have to go from yards, yards down to inches, and then centimeters, and then back up to meters. So the first question we have to ask ourselves is, do you know how to get from yards to inches? Well, let's pretend that we don't. Let's pretend that we have to go from yards to feet, and then we'll go from feet to inches, and then we'll go from inches to centimeters, right? That'll be the portal we'll climb through. And then we'll crank it up from centimeters to meters, and that's where we want to be, right? I didn't have room for an equal sign, but just pretend. All right, so these are our steps. We double check. Do we need to do it twice? No, we do not, because this is obviously a conversion of length because there are no squares or cubes. 32 yards to meters. So that's just one dimension. So we don't have to do any of these multiple times. All right, here we go. I'm going to go kind of fast because we've already warmed up and there's a lot of these. All right. We want yards on the bottom. We want feet on the top. A yard is bigger. There are 3 feet in a yard. Those cancel. We're now in feet. We want feet on the bottom. We want inches up here. We want to be able to cancel. A foot is bigger. 12 inches in a foot. Cancel, cancel. We're now in inches. Okay, here we go. Through the portal. Inches down here. Centimeters up here. An inch is bigger, and there are 2.54 centimeters in an inch. This one is very important that you memorize, okay? Inches cancel. Now we're in centimeters. That's where we want to be. We put centimeters on the bottom. We put meters up here. A meter is bigger. And remember, oh yes, centimeter, that's 100. All right. Beautiful. So now we are ready to just bring this all together. So it will be 32 times 3 times 12 times 2.54 all over 100. And then our final answer, oh, I forgot to cancel those. There's our meters. Oh, I'm sorry, I shouldn't have the equal sign there. Meters. That's our final answer. Double checking to make sure. Yes, beautiful. If you're the kind of person who can remember that there are 36 inches in 1 yard, then you could combine these into a single step. If you know that and you feel comfortable with that, you can use that. I think that's pretty normal for some people to know this one. If you don't, that's okay. Just go from yards to feet and feet to inches. But if you can do that in a single leap, I authorize you to do so. All right, this is the correct answer. And now let's do the second problem of this type. These are a little trickier because we have to climb through the portal. So we have to wind our way down to inches and then go to centimeters and then climb back up to the other side, right? That's how I think of it, is that we're kind of like in, we're up here in yards, and then we have to go down to feet and all the way down here to inches, to centimeters. That's where we can climb through the portals, and then we have to climb back up to meters. To me, it's like a journey of dipping down to this special place where we can segue between the two. Okay, last one. Enough of my pictures and wacky metaphors. Use unit multipliers to convert 0.042 square kilometers. Okay, so I automatically write 2 of these, and I make a note to myself, oh, we're doing everything twice, right? No more easy days for us. And we want to end up in square miles. So I'm going to write miles in miles. Note that meters is a plain M, and MI is miles. If that confuses you, let me write it down, because that is confusing. All right? Plain M means meters, MI means miles. Okay, so we can see right now, not only do we have to do everything twice, but we have to go from kilometers to miles. So we've got another one of these situations. So let's figure out how we're going to do that. We'll go from kilometers to meters, from meters to centimeters, from centimeters to inches. Oh, Lord have mercy, I'm going to do a second row now. From inches to feet, and then from feet to miles. And each one of these we're doing twice. Am I kidding right now? No, I am not. All right, let's draw some boxes. We're going to do 3 in this row, and then we'll do 2 more down there. And 2 times for all of them. So when we summarize our answer, we'll have to keep that straight. This is a lot of unit multipliers, right? Okay, let's dive in. Kilometers to meters. We want the kilometers on the bottom. We want the meters up here. Kilometers bigger, that's the like miles in Canada. Meter is half your dad's height. There are 1,000 because kilo means 1,000. Okay, we did it twice, so I can cross that off twice. Now we're in meters. Meters, centimeters, a meter's bigger. Centimeters, cent implies 100. Cross off 2 meters, there we are, okay? Centimeters to inches, climbing through the portal. I have a very distinct picture in my mind. It's kind of like in the desert, and we're in a little cave, and we go out of the sunshine, right? And we climb through this little hole, this little cave, and then we come out on the other side, and we're in metric land. Okay, so now we're doing that. Centimeters and inches. An inch is bigger. This is 2.54. We have to do it twice. We cancel those. Now we're in inches, so now we're going down here. We want inches on the bottom, feet on the top. A foot is bigger, 12 inches in a foot. Cancel, 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 cancel. Now we're in feet. Feet to miles. A mile is bigger, 5,280. Make sure you know those numbers. I know they're confusing and weird, but make sure you have those memorized. They're easy to find in the book, or you can always Google them, but I want you to memorize them so that you know them hard. Okay, I didn't do my thing. Here's my inches canceled. I'm in feet. Now my feet cancel, and I'm in double miles, and that's what I wanted to be in. Okay, so for my final answer, I'm going to squish it down here. It's going to be kind of messy. It is no, I can't do that to you. I should have flipped the page. I'm filled with regret and remorse. Oh well. 0.042 times 1,000 squared, because I need to do it twice, times 100 squared over 2.54 squared times 12 squared times 5280 squared. 5280 is not really the proper way to say that. It's 5,280. That does not represent 52 unless I say 5,200. But anyway, okay, so there are all my pieces. I remembered to square everything because I'm doing it 2 times because it's a conversion of area. And then my ending unit is miles squared. Let me see if I got it right. 0.042, 1,000 squared, 100 squared. Yes, that's a little baby 2. It's hard to see. Yay. This is my final answer. That's pretty hard, isn't it? But once we kind of get up to our cruising altitude on these problems, you go, okay, well, it's a lot and it's kind of a mess, but you just keep going. Using these shorthands to write each unit multiplier only once. Just think, it would be 1, 2, 3, 4, 5. We would have 10 of them if I didn't use that shortcut. All right. What I think is really important in these problems is understanding your roadmap, how you're going to get from one unit all the way to the other. And you'll notice that the stepping stones we have to use to cross this river between the two have become quite complicated, haven't they? We're going through valleys, we're climbing through portals. It's a bit of a mess, but hopefully it made a certain amount of sense to you. Okay. And remember, in these last 2 problems, we were going from English to metric, or vice versa. It doesn't matter, right? It just means we use the multipliers upside down. All right, that's all I want to say about conversions. I think that's plenty, don't you? You probably wished I would have stopped a problem or two back. Now what I'm going to do is show you, we're going to take another kind of problem, just a baby step forward, and show you one more little wrinkle that we can do. In these problems, we're talking about these chemical compounds. We did these before the break. There was one of these problems on the test, if you went through that lovely experience with me. And we're going to do all of the work that we're used to doing, all right? So we've got a compound. It looks like this. Na2S2O3. Remember, we do not really have to understand this except to know that these represent different elements or types of atoms, and this is the recipe that tells us how many we need to brew up this particular compound. And we read, it says there are 2 atoms of sodium, Na, 2 atoms of sulfur, S, and 3 atoms of oxygen. Okay, well that helps make a little more sense of it, right? And then we need to know how much each one of these things weighs, right? And John gives us that information thusly. And this is information that some kind soul has dragged off the periodic table of elements for us. And it tells us how much each of these elements weighs. So this tells their weight, this tells how many we need, and we can use this to build our cool and groovy chart. This chart needs to have room for 3 different elements. And then we also need a total row, although we don't need that in every column that we're going to create here. So we start by listing the different elements. I just go to my recipe, Na, S, O, and then total. And I didn't extend my columns up enough, so I'll have to do that. We're going to need I think 4 will get the job done. 4 more. If you've got the room, you can make, ooh, that was wobbly. I'm gonna make a 5th one, and that will give us a place to do a little calculation. That'll be cool. Okay, so the first thing we wanna do is we need to know the number of atoms that we're using to brew up this recipe. That comes from this information. 2, 2, 3, and we don't need any information about a total in this. Then we need to know what we call the atomic weight. That comes from here. 23, 32, 16. And again, we don't need a total for this. Now we're going to calculate the total weight, which has a fancy name. We call it the gram molecular weight. I'm not going to use such sciencey words. I'm just going to write total weight. So if we think of it as an ingredient, we need 2 cups of sodium. Each cup of sodium weighs 23 grams. So the total weight of the chocolate, of the Na, I'm thinking of them as chocolate chips, is going to be 46, right? We just multiply. The sulfur, we need 2 cups of that. Each cup weighs even more. They weigh 32 grams each. So this is going to be what, 64. The oxygen, we need 3 cups of that, but it's only 16. So we multiply it out and we get 48. Now we know how much each of the ingredients is going to weigh when we make our special recipe. And now we can find a total for that. That would be 8, carry the 158, right? Okay. Now, what John is asking us to find is what percent of the total weight each element represents. That's what's new in this problem, is he wants us to find the weight by percent. Okay, well, we've got the weights all here. We've got a total. So this is our calculation. For the sodium, it's going to be 46 over 158. All we have to do is grab a calculator and find that number, and that will give us the percent of this compound that we've made that is the sodium. Then we can do the same thing. The sulfur is 64 grams out of a total of 158. So this, converted to a percent, will be the percent of our compound that is sulfur. And then we do the same for the oxygen. It's 48 out of 158. Okay? So this is new, making this little calculation, but it's super easy. We just take these, right? And then obviously this would be the total. And then again, I'm fine with you using a calculator to do this. This would be 29%. If you calculate this, it's 0.29, and we would present that as a percentage. This comes out to 0.41, so we would write it as 41%. And then this one would come out to 0.30, so we would write it as 30%. And then, if we've done our work correctly, these should add up to 100, because the total should be 100%, right? So let's see, there's a 0, carry the 1, 3, 7, 10. Okay, so it does. It adds up to 100%. And this is what's new. This is how we calculate it. So these two columns are the new ones, right? We're finding the percent of each element in the total weight of the compound. All right? So that's just one more way that we can work with this information. Here's example 53.5 just asks, what percentage by weight of this is sodium, Na? Well, we have it right there, it's 25. So, or 29, I'm sorry, I can't speak. What I was writing is that. We can write that as an answer if we want. What percent by weight Okay, this is how John asked the question. What percent by weight is the sodium in this compound? So we've already calculated it. There's the sodium. There's the percentage of the total weight. So we would say 29%. Okay? I like these problems because we've already done all the heavy lifting of understanding how to make this chart. We just take this column with the total weights and we create these fractions that show us that element over the total element, and then we calculate the percents off that. All right, guess what? I don't have another single thing to say about this. And so I'm sorry, but I'm just going to have to be done. Thank you. Goodbye.